For this type of factoring, I call it DOTS, and it stands for difference of two squares. And it is one of the simplest forms of factoring. And there are three requirements. It has to be a difference, meaning that it has to involve subtraction. It has to be a binomial, so there are only two terms. And it has to be perfect squares, meaning that this term has to be a perfect square, and this term has to be a perfect square. So first thing you want to do once you recognize that something is a difference of two squares is you set up the double bubble. So you want to get your binomials ready. One binomial is plus, the other is minus. That's what makes that middle piece cancel out, because as you can see over here, there's no middle piece here. You want to put the square root of each term in its respective spot. So the square root of this term goes first, and the square root of this term goes second. And then you always, always, always check. So let's check out a couple examples, and you'll see how quickly this is done. X squared is x times x, and 25 is 5 times 5. So this meets my three requirements. It's a difference, it's a binomial, and each term is a perfect square. So I set up my parentheses. The square root of x squared is x. The square root of 25 is 5. One is plus, one is minus, and there you are. You want to double check using FOIL. X squared minus 5x plus 5x minus 25, and you know these would cancel, so it checks. Letter B. 64 is 8 times 8, and this is y times y. So it fits my three rules. The square root of 64 is 8, and the square root of y squared is y. It doesn't matter, just for giggles, I'll make this one minus and this one plus, and then there you are. Let's check it out. FOIL. 64 plus 8y minus 8y minus y squared, and then these will cancel. Last one with me. This is 2z times 2z, and this is 1 times 1. So be careful if you have a monomial that looks like this with a coefficient, it can still be a perfect square. So 2z, and then 2z, and then 1, 1. Make one of them plus, one of them minus, and then I'm just going to check FOIL. 4z squared minus 2z plus 2z minus 1, and those cancel, so I'd get it. Try the next three, A, B, and C, on your own. Pause. All right, when you're ready, check out example 3. A bird picks up a golf ball and drops it while flying. The function represents the height in feet of the golf ball t seconds after it is dropped. The ball hits the top of a 32-foot pine tree. After how many seconds does the ball hit the tree? So we check out our labels, and y is feet and t is seconds. The only other thing with labels that we have in here is a 32-foot pine tree. So what they're saying is that when the ball hits the tree, its y value is 32. So I'm going to take my equation over here, this tiny thing, and I'm going to plug in 32 for y. Okay, in order to solve this, and use that zero product property that we've been using a lot, we have to get the 32 to the other side. And now that I have it equaling 0, then I can factor it. Remember, you can't factor if it's not equal to 0. So that's 7 minus 4t, and this is 7 plus 4t. So they want to know the number of seconds. So there, I'm not finished. I have to actually solve this and use that drop a line technique and say, well, 7 minus 4t could be equal to 0, or 7 plus 4t could be equal to 0. So I'll solve this one. And that is, I'll do it as a decimal, that is 1.75, and 4t, that is negative 1.75. So that clearly is a ridiculous answer because you can't have negative seconds. So the answer must be 1.75 seconds. If you have any questions, write them down and ask me when you see me in class.